Hello pupil, welcome to Easy Science for All. In this part 2 of Resistors in series lecture, we will try to find out relation between V, V1, V2 and V3. As you can see, here V is the potential difference across series combination A and B, whereas V1 is potential difference across resistor R1, V2 is the potential difference across resistor R2, and V3 is the potential difference across resistor R3. Consider following three resistors R1, R2 and R3, where R1 is equal to 1 ohm, R2 is equal to 2 ohm and R3 is equal to 3 ohm. Join these three resistance in series as follows. So this is a series combination of three resistors. Series combination of three resistors. Now connect this series combination, this series combination of three resistors with a battery say of 6 volt. I have taken an example. I have taken a battery of 6 volt here for the experiment. An ammeter, a plug key, and join this series combination and form a circuit in the following manner. Here I have joined this series combination between 2 points A and B and formed a series circuit like this. Now with the help of a voltmeter, we will measure the potential difference between points AB, then XB, then QS, then TY, and we'll try to find a relationship between these potential differences. Let I be the current flowing through this circuit, and with the help of this ammeter you can find out that it will give a reading of 1 ampere. So for this combination, right now a current of 1 ampere is flowing through each individual resistance R1, R2 and R3. In the first step, we will measure potential difference across points A and B. For this, we will insert a voltmeter device between these 2 points in the following manner. As soon as you join voltmeter with points A and B, you will see that it will give a reading of 6 volt. So it means that the potential difference across points A and B is 6 volt. Now please remember here that we are taking the help of devices like ammeter and voltmeter to measure the value of current in the circuit or to measure the value of potential difference between 2 points. We are not calculating it numerically. Let us denote this potential difference between A and B points as VAB. So it will be equal to 6 volt. In the second step, disconnect the voltmeter from points A and B. This is B point, and connect it or insert it between points X and P in the following manner. On doing this, you will see that the voltmeter is giving a reading of 1 volt. It means that the potential difference across points X and P will be equal to 1 volt for this particular combination. I am repeating it again and again that this reading will be for this particular combination where I am using a battery of 6 volt and 3 resistances R1, R2 and R3 are connected in series. Let us denote the potential difference across points XP as VXP. So VXP will be equal to 1 volt. So till step 2 we have got two values, VAB is equal to 6 volt and VXP is equal to 1 volt. In the third step, again disconnect voltmeter from points X and P and insert it between points Q and S in the following manner. You'll find that the voltmeter will give a potential difference of 2 volt or indicate a reading of 2 volt between points Q and S. So the potential difference across points Q and S would be 2 volt. Let us denote this potential difference by VQS. So it will be 2 volt. So right now we have three potential difference values, VAB which was equal to 6 volt, then VXP which was equal to 1 volt, and now we have VQS equal to 2 volt. Again repeat the third step and insert the voltmeter now between points T and Y in the following manner. You will see that in this case the voltmeter will give a potential difference across points XY as 3 volt. Let us denote this potential difference by VTY and let us call it VTY and it will be 3 volt. So now we have four values with us. VAB is equal to 6 volt, VXP is equal to 1 volt, VQS is equal to 2 volt and VTY is equal to 3 volt. Now if you look at these four values carefully, you will find that the sum of VXP, VQS and VTY, it is equal to the value of VAB. In other words, the potential difference across series combination AB is equal to the potential difference across individual resistance R1, R2 and R3. So we can write this relation in the following manner. That is, VAB can be written like the summation of VXP, VQS and VTY. In general, if more than three resistances are connected in series like this is, let us say R1, R2, R3, R4, R5 and so on. R5 and V1, V2, V3, V4, V5 is the potential difference across these individual resistance, and the potential difference between these 2 points, this point and this point, it is V. Then you can write it like this, that V is equal to sum of potential differences across individual resistances. So this can be extended for n number of resistors. If there are 10 resistors connected in series, then you can extend this summation to V10 also. One more thing that has to be noted is that if I connect the voltmeter between the positive and negative terminal of this battery, then this voltmeter will give me a reading of 6 volt. If I denote that potential difference between the two terminals as VB, then it will be 6 volt. Now if I compare this and all these value, so I can write the relation like this as well. The potential difference between the terminals of the battery is equal to the potential difference across the series combination, which is equal to the sum of potential difference across the individual resistors VTY. So this thing has to be kept in mind while dealing with a series combination resistor problem. So in the end of this lecture, we can conclude that the total potential difference across a combination of resistors connected in series is equal to the sum of potential difference across the individual resistors. That is, V is equal to V1 plus V2 plus V3 and so on. If you have any further queries regarding this lecture, please comment this video. I'll revert back. Thank you.